Section 2.2 Role Types. So quick recap, the three types of companies we said: AI producers, AI consumers slash producers, and end users. And we'll look at the different roles today in this section within the context of these three types of companies. You might want just become a data analyst or some kind of business analyst in one of the end user companies who are not producing AI products, but they are consuming AI products and they're using AI within their processes. Or you might want to become a data analyst or a data engineer or a machine learning engineer in the AI consumers, or even a data scientist. Or you might become one of these roles and pursue one of these roles at the AI producers, which is the top tier globally known companies that work in AI. Also, a quick recap on the analytics maturity curve. People are going to be hired throughout this journey as an organization or a company moves from stage 1 to stage 5, as well as all of the levels on the vertical axis. So they might be a flat organization. By the time they get to the final stage, they might be a quite sizable organization with multiple new units. And this is where the different types of roles that are hired become more relevant. So as the organization grows and hires more people, the different types of career options available to you in these organizations are very many. They keep emerging new roles. The more mature the company, the more nuanced the roles. So if you look at some examples of roles in the big companies like Google and Microsoft, etc., you will see that they have a whole host of different types of roles, such as AI sales engineer, for instance. Now, this is a role which is going to be part of the sales organization rather than the technical or development organization. This person will have a technical background and will be aware of the product, how to run it, perhaps even aware of the algorithms that underpin the product as well, so they can have a meaningful, deep conversation with customers and clients. But they're still not part of the development of these products, as they're part of the sales organization. Similarly, you might see experimental designer as a role somewhere in a more mature organization, where this person might have a research background or any other discipline where they are familiar with how to run experiments, how to set up a design, how to test different hypotheses, etc. So coming back to the list that we have put in front of us, of course, there's the C-suite additions that we mentioned last time as well. If hypothetically an organization is introducing a new unit under a chief data officer or a chief digital officer or a chief AI officer, then you can have different roles underneath within this organization, including a statistician or a market research analyst or a data scientist and MLE, a machine learning engineer, or a data engineer and architect, even DevOps engineers, MLOps specialists. They may even borrow business analysts from other parts of the organization on project bases, for instance. So recall our example from the end of the previous unit. We're adding a new subunit or department within an example organization. And we said that we look at 5 different types of roles, from technical to business spectrum. We said the data engineer was the most technical, and then MLE and data scientist were straddling both worlds, a very technical role with a very strong business sense and acumen. And then data analyst and business analyst moving more towards the business. So now we will look at these 5 and take an in-depth look at all of them. Remember from our preview of this section 2.2 slide in unit 1 towards the end, all of these 5 roles had a lot of overlap, and this was illustrated with the following spider plot on the screen. Let's do a quick refresher so that we have a good basis for the next slides. Data engineers building pipelines for the data, it organizes the data, works on the pipelines for data ingestion, and supports the machine learning engineer together to deploy models. The machine learning engineer applies data models, connects the data scientist and the engineer, has a background mathematics, statistics, computing, understands ML and ML ops and deployment as well. The data scientist is creating the data models, the actual statistical models, interprets the data, improves the results, extracts value for the business. The data analyst is doing ad hoc analyses, focusing on cleaning and preparing the data, ensuring the quality and integrity of the data is there, identifying trends, visualizing and exploring, understanding the KPIs and business metrics and monitoring using the data, reporting to the business if there's a deviation. The business analyst, in the end, of course, is looking at the needs and requirements of the stakeholders and the business functions, insights for the business, aligning with the strategy and communicating with the stakeholder, understanding the processes and collecting and understanding the data, also doing business charting and presenting and leading workshops with the business. So looking at the spider plot, we have the data engineer focused on the databases, the pipelines, the ML ops, and a bit of deployment. The ML engineer focused a bit on databases and pipelines, but mostly on ML ops and deployment. Supports the data scientist with statistical modeling and inference a little bit, and even experimentation. The data scientist is involved in deployment to some degree, maximally involved in and leading statistical modeling, inference, experimentation, supporting reporting and storytelling, and getting engaged with the business as he straddles the two worlds, and reporting on business insights and extracting business insights. Of course, in doing so, a bit of visualization as well. Data analyst, then, the one in yellow, is supporting experimentation with the scientist, maximally involved in reporting, and also getting involved in the storytelling, business insights, and data visualization. And finally, the analyst, the business analyst, focused on reporting and storytelling, but maximally on business insights as well, reporting it back to the stakeholders, collecting it from the business stakeholders when it's requirement elicitation phase as well, and a slight role in visualization of data where they're developing business charts as they communicate with the stakeholders. So this brings us to our first role and a deep dive. We'll start from right to left, so we'll start with the business and get more technical, and then we'll come back to the middle to end with the data scientist. So the purpose of a business analyst is to bridge the technology and the data teams with the business function. Of course, they need to have a clear communication to align with the stakeholders. They need to understand business processes, as we've said before, and they find and highlight areas for improvement in the current processes and strategy and business operations. The responsibilities is, of course, requirements elicitation, thorough understanding of business ops, collecting data and doing some initial exploration and spotting trends and patterns and business charts to promote common shared understanding across the business. They need to be well versed with process modeling and documentation to improve workflows and look for any areas for automation to enhance efficiency. They support tech teams in development of the solution, implementation, validation as well. They do stakeholder documentation, presentations, workshops, comms, and even validation, as I said, of developed solution. So in a way, we can call them alpha testers as well, because they're the first point of contact when a vanilla version of a solution is ready for them to validate this from a business perspective. The kind of skills that are needed for business analysts include the ability to work collaboratively, of course, with cross-functional teams, excellent analytical and problem-solving skills, strong communication, interpersonal skills, excellent documentation, presentation. But moving into a bit more concrete skills, data interpretation, exploration, they should be very proficient with Excel-based analysis. They should know some tool suites for business process modeling and documentation, some project management methodologies and tools as well. They need to be able to understand and recognize conflict, be able to manage it as well, because they're connecting the technical and the business domains, and hence mitigate risk. And in terms of qualification, there's a variety of backgrounds, generally business, management, finance, economics, etc., or a related discipline that they might have a degree in. Let's look at the data analyst role then. The purpose of this role is to collect, process, and analyze data sets. Generally, this analysis is statistical analysis. The data analyst derives meaningful information from data to generate insights for decision making, facilitate the business, the executive committees, all levels to make more streamlined and effective decisions driven by data insights. The data analyst also oversees data and reporting integrity and precision, so looking at the quality of the data, highlighting what are the gaps and improvement areas. In general, the responsibilities, of course, is an oversight of the databases and the data systems collectively within the organization. They also explore this data to spot patterns and relationships, of course, for formulation of hypotheses, which will generally be inductive or be guided by a deductive business-driven hypothesis that's come in. They will clean the data, prepare it for analysis, their own exploration, as well as further analysis down the line. This generally includes imputation, filtering, transforming, etc. As part of the exploration and preparation, they also create charts and plots and even dashboards to facilitate a better common shared understanding. They present these charts and these reports in presentations to project and executives, leadership teams, and thus influence data-driven decision making. The analyst also streamlines processes and reduces costs and increases productivity directly or indirectly by generating these data insights. And finally, they work with the technology, engineering, and product teams on the business requirements together. In terms of skills, they of course need to be well versed with statistics and relevant tool suites such as SPSS or SAS, some kind of programming or scripting ability in, let's say, SQL for databases, and Python or R or MATLAB. Machine learning methods, even if it means basic to intermediate understanding and application. Database querying and management, of course, they need to be analytical, be able to think critically. Attention to detail and thoroughness, of course, anyone who works with data has to possess this skill for them to be able to generate accurate and precise information from data. Excellent communication and presentation skills, they should be able to do this for levels of all audience, laymen through to the experts, write reports and document their work. Time management, domain knowledge, of course, this applies to most roles. If you have at least an industry knowledge of one domain or industry, this is quite desirable. And then project management, risk mitigation, stakeholder workshops, etc. This is where all team members contribute, and especially with the data analyst working together with the business analyst who is leading these events and generally gets involved there. In terms of qualification, the data analyst normally or typically has a computing or IT background. They might even come from a statistics or a maths background, or even an information management discipline or a related field. So the data engineer then, the purpose of this role is to, of course, collection and storage and management of data. They bring this together in a single source of truth so that it's already cleaned up and ready for consumption by the machine learning algorithms and pipelines. They build and maintain the data architecture and the infrastructure for data analytics. If the current state is not supporting let's say a continuous integration and delivery pipeline, then the engineer will get involved in drawing out the future state architecture and help with that migration as well. In terms of responsibilities, they're collecting data from various sources, much like the analyst and the business and the data analyst, but in this case this is more technical in that they are integrating these sources through APIs or streaming the integration is not file based. The engineers will build efficient data pipelines to integrate these various sources on the fly. They're also responsible for storage and management of quality, data quality, performance, integrity, and scalability. They developed extract, transform, load pipelines for analytics ready formats. They should be dealing with big data technologies to process very large data sets. And they handle all types of data, including structured, unstructured, and semi structured. Or typically, if they have a background in distributed systems or cloud computing, this is quite handy. They could also come from a database background, really. In terms of skills, they need to have, as I said, relational, non relational databases, understanding and experience with SQL, NoSQL, Python, R, or perhaps even Scala, which is desirable. ETL systems they should know, and they should be familiar with data lakes and data warehouse and data marts, automation, scripting, bash scripting, etc. Big data tools including Kafka, MongoDB, Hive. If they know one of the main hyperscalers, this is quite handy. In terms of data security, they also need to be able to support the security team, or even if in small organizations, if there isn't a security team available, then the data engineer looks after data security on their own. If they know basics of machine learning, this is quite desirable, but generally this is an overlap with machine learning engineers. In terms of qualification, computer science or a related discipline background. Machine learning engineer then, the purpose is to support the data scientist in developing and designing and deploying the machine learning models that have been developed. They will maintain and enhance existing models in production. They normally connect the data scientist and the engineer. Responsibilities for the MLEs being machine learning engineers for short, include performing statistical analyses, implementing ML algorithms, running experiments and tests, studying and transforming prototypes, proof of concepts, and applying appropriate ML algorithms. They also run some tests and experiments and document the findings and results. This is hand in hand with the data scientist. They train and retrain and monitor machine learning systems and models as needed. They also construct optimized data pipelines to feed ML models and extend, perhaps, if the ML libraries and frameworks as well. In terms of skills, they should have an understanding and background in computing, math, stats, and algorithms. So this is quite a technical role. The data modeling, and they need to be aware of data modeling, data structures and architecture, programming in one or more languages, the different machine learning frameworks, libraries that are out there like SciPy or PyTorch or scikit-learn, etc. They're very much involved in model deployment, so that's a major skill. And then they need to be able to collaborate and cooperate and learn continuously, as this is a very dynamically moving and emerging field. In terms of qualifications, generally they come with a computer science or a data science or maths or stats background. And then finally we come to our data scientist, which is the role we will be focusing on in this particular course. The purpose of the data scientist is to interpret data, extract meaningful patterns, run experimental designs and test hypotheses, develop solutions that are driven by data using statistical models and machine learning algorithms to support business functions and processes. They must have business sense and acumen and communication skills to influence leadership, because whenever, more often than not, when insights are gathered from data and solutions are developed, there is a change in process or in the organization that is required, which needs executive sponsorship and approvals. And this can only happen if the data scientist is able to build a narrative and take that story to the rest of the organization and socialize it so that there is consent and progress. In terms of responsibilities, the data scientist uses machine learning and AI, as we saw, NLP, computer vision, to develop solutions that are going to solve very complex problems. They do pre-process the data that's consumed by the ML, and here they are assisted by the data analyst and then the engineer as well, the data engineer. They develop on big data platforms such as Spark, and they create and learn ML features, which could be a supervised or an unsupervised learning using neural networks. And they develop machine learning models, optimize the developed models. They should be able to use both structured, unstructured, even semi-structured data. And they do storytelling and narrative building to connect these findings to the problems and then drive value by gathering consensus, showing empirical results, and then paving the way forward for the process change needed to adopt this solution. In doing so, they help the executives optimize strategies and hence bridge the technical commercial gap. And this is a very, very important subject, which is why we have a separate unit on this. In that unit, we will be looking at how data scientists are able to bridge the technical and the commercial gap, because this exists in every organization where there are technical teams that are siloed, there are the commercial business functions which are siloed, work together with great difficulty. They have very different processes, and the flow of information, cooperation, collaboration, and coordination is not very smooth. And the main role of the data scientist is to understand the problems, the business functions, and the commercial angle or side of the business, and be able to look at what data exists, create solutions, and solve those complex business problems, and then connect these two worlds together with a narrative that they build, which is very complex, but they have to simplify it so that it's understood by the lay audience, by anyone in the company. And this is the way to drive consensus, but more on this later on in this course. The data scientist needs skills that are a blend of technical, business, analytical, communication skills. They need to have programming competency in various languages. Of course, they need mathematical and statistical analysis, statistical tests, statistical distributions, basic and intermediate methods related to supervised learning, neural networks, support vector machines, probabilistic Bayesian systems, and the underpinning calculus and linear algebra, which is very important for a data scientist to be able to tweak and change and adapt algorithms and methods and even apply them in an informed way when they're dealing with data and trying to model. They should be able to do data visualization with libraries such as Seaborn, etc. Even though these might be quite scientific and complex in the beginning, they should also be able to turn these into business consumable versions which are developed together with the data analyst and the business analyst. They should be able to communicate with varied audience. Organizations run lunch and learn sessions where anyone can join in to see what progress has been made on a certain project, or if there's a new breakthrough and innovation, then the data scientist and team can bring this to a lunch and learn session, for instance, to showcase it to the rest of the organization regardless of their work type or function. This kind of events are quite useful to build consensus across the organization. As we said, data scientists need to have business sense and acumen. Without this, they won't be able to bridge that techno-commercial divide or gap, as we say. In terms of qualification, there's a very varied background, really. Could be a researcher coming from a very different background, but dealing with data from experiments, for instance, clinical research or cancer research. They could be from a computing background or an economics background with econometrics skill set moving into data science. They could be from a maths or stats background or any other quantitative discipline. If they do have a strong software engineering background, this is quite helpful generally in developing production-ready solutions that are deployed, but this is not a must. Where do these roles fit in the data science life cycle then? So if you recall from the first unit we saw in the very first lecture or so, the data science life cycle, which helps guide us through the process of developing a data-driven solution. Just a quick recap to jog our memory. We start with the business problem understanding, and then we move into data collection and understanding, cleaning and preparation of it, visualizing and exploring it, testing hypotheses, machine learning, then moving into evaluation of the model, optimizing it, deploying and operationalizing it. So when we see where business analysts come in is, of course, around the business understanding and problem understanding phase, the very first one, where they're going to liaise with the stakeholders from the business function counterparts, understand what kind of data is there, what the problem is, what processes exist, who's responsible, what's the current state of practice. Once the data comes in, then the analyst first gets involved in looking at the samples and understanding it, but even the engineer might get involved in a discussion or two just to have early sighting of what kind of data is coming in, just to see the schemas, etc. And then later on, when the pipelines are built, they are ready with this knowledge. Then you have the analyst and the engineer working towards cleaning and preparation, and mainly but the analyst, but the engineer would also perhaps get involved for early sighting or to support. And then we have the fourth stage, visualizing exploratory analysis, which is where the scientist first steps in. Of course, the data scientist is generally leading this process, so they have sighting of all of the stages, but hands-on work will start around here when they're starting to explore, check with the data analyst, start to model, run simple models, etc., explore the data from various angles, merge with different types of data, see what else could be done, what data isn't available that might help. And this is where the business analyst also contributes by going back to the business, and then they might find out that the business has another data stored elsewhere in a silo or with another business function. They might bring that in as well, or the team might find that there is other data to be found with proprietary data sets on the web, or even open source publicly available data sets. Everything comes together here so that you can start getting ready for hypothesis testing and machine learning. And this is where the data scientist and analyst work together. When it comes to machine learning model building, the ML engineer comes in as well, because they're going to be optimizing and helping the data scientist with the application of the ML methods, especially with a view to deploying those models and maintaining and monitoring those in production. And that's when the data scientist and ML engineer move into the next stage, evaluation, moving into optimization together, and eventually deployment, operationalization, which is where the engineer comes in as well. So where do these roles fit on the analytics maturity curve? Just to bring it all together and just to integrate what we have already learned now in terms of the analytics maturity curve and the 7 facets of the analytical journey for an organization that's guided by a strategy. We saw all of this, and if you remember, we put 5 stages on this maturity curve from left to right on the x-axis, with the business reporting being the least mature and data science AI being the most mature. And then we also put levels on the vertical axis, these levels being different types of analytics that the organization is undertaking. And of course, if we look at the people then from this perspective and remove the levels, so that we can see the roles in comparison or contrast with the 5 stages alone. So let's say the business analyst is getting involved in business reporting and a little bit in business intelligence. So in stages 1 and 2, business analyst is very much active and must be present in the organization. And then the analyst, once it's moving from BI to more ad hoc analysis as well, that needs hypothesis testing and further application of the scientific method. And then once you start to move into the 4th stage with data mining, then the scientist comes in together with the analyst to develop different models. And then over here, you also start thinking about building, or organizations rather, start to think about building data pipelines and bringing everything into an integrated single source of truth, rather than the ad hoc analysis that are happening in silos or on files or on only some parts of the data from different functions in the business, but not the entire organization. So the engineer and the scientist are very much active here, and now the organization is moving into the 5th and final stage, and that's where deployment of models will start to happen as well. And the engineer, especially the ML engineer, will start to feature with the deployment of the developed models and monitoring and maintaining those in production. And that brings us to the end of this session. I'll see you in the next one. Thanks.